Hi guys, here we are working on Unit 2, Section 3. This is solving exponential and log equations. A couple things before we start. We need to remember that exponential and log, they are inverses of each other. The base is always the base. And something else that is going to help us solve the equation, and that's what we're doing in this unit. So if the bases are the same, the arguments are the same, which that's easy. Now, example 1, if the bases are the same, which they are, the exponents are the same. So here we can use this for two things. If the bases are the same, arguments are the same, in this case right here. And then we're going to solve. In this one also, if the bases are the same, the exponents are the same. So here we set them equal to each other. This exponent equals this exponent because the two bases are the same. So 3x minus 2 is negative x, plus x on both sides, I get 4x, plus 2 on both sides, I get 2, divide by 4, simplify the fraction, I have 1 over 2. Now, for the second one, the bases are the same, I know the arguments are the same. So the two bases are the same, now the arguments are the same. So negative a minus 3 is a squared minus 33. Now, this is a quadratic equation. I will set it equal to 0 and solve. So I'm going to make this one 0, add a to both sides, add 3 to both sides. Let's go ahead and solve this by factoring. So two numbers that multiply to negative 30 and also add up to positive 1. Positive 6, negative 5. Okay? Set each factor equal to 0 and solve. So I have a equals negative 6 and positive 5. Now we need to check for extraneous solutions. What does that mean? Well, I know I cannot take the log of a negative number or 0. So here, if I plug in negative 6 for a, negative makes positive 6 plus minus 3, that's positive 3. So 6 works. Now if I plug in 5 for a, I have negative 5 minus 3, that's negative 8. So I cannot use that one. So I cannot take the log of a negative number. So 5 is extraneous. So my final answer will be a equals negative 6. So this is the solution. Now the extraneous solution is a equals 5 because 5 doesn't work for the argument right there. It will give you a negative argument right there. Now I have log base 4 on both sides. That tells me that the arguments are the same. So x minus 2 equals 5x minus 7. So then I'm going to solve for x minus x on both sides. I have 4x right here. Add 7 to both sides. I have 5 right there. Divide both sides by 4. I have x equals 5 over 4. Now a quick check. I have log base 4 of 5 over 4 minus 2. Well, when I plug that 5 over 4 minus 2, it's going to give you a negative argument. 5 over 4 minus 2, that's going to give you a negative argument. So even though we did everything correct, I cannot end up with a negative on the argument. So I cannot take log base 4 of negative 3/4 or negative 0.75. So this one cannot be negative. The argument cannot be negative. Therefore, There's a no solution on this one. So easy, bases are the same, exponents are the same. So for x minus 7, negative 37 plus x. So here I have minus x on both sides. I get 3x right here. Add 7 here. I get negative 30. Divide by 3. I get negative 10. The good thing is the exponential function, you don't have to check for extraneous solutions. I'll see you next.